This is the screencast for section 2.1, example 1, polynomial functions. So a polynomial function is something that you have seen several times, but probably not laid out in this really confusing form, because we all know that mathematicians like to brag about how smart they are by making things more complicated than they are. What this means, f of x equals, all these a's are the number in front of the x's. So those are the coefficients. So a sub 0 is like the last coefficient. It doesn't have any x's. As a matter of fact, it has an x to the 0. Get it? X to the 0 power. Then the next one is x to the first. The next term is x to the first with a coefficient, and that coefficient is nicknamed a sub 1. So like the first a, but it's really the second a. It's hard to explain. Then x squared is a sub 2. It's nicknamed a sub 2. Then we would have the x cubed term with a sub 3. The x to the fourth term is a sub 4, etc. Now this last one out here is x to the nth power. So say that's 10. That's x to the 10th power, which means you'll have a sub 10. Now the one to the right of it would be x to the 10 minus 1, 9th power, and a sub 9. So they're just nicknames. All these a's are nicknames for the coefficients. Example 1, identifying polynomial functions. Which of the following are polynomial functions? For those that are polynomial functions, state the degree and leading coefficient. For those that are not, explain why not. Okay, so first of all, the degree of a function, according to this definition up here, is n, and n stood for my highest exponent of x. So in the example I gave, where x, this last term here was x to the 10th, this would be a 10th degree polynomial. The leading coefficient then would be the coefficient with that term. So a sub n might be 5 or negative 2, whatever the number is in front of that x to the 10th. So part A looks like a polynomial to me. 4x cubed minus 5x minus 1/2. There's no x squared term there, but that's just because its coefficient is 0. So it's like 4x cubed plus 0x squareds minus 5x minus 1/2. So this polynomial would be degree 3, and its leading coefficient would be 4. Now B, I see an x to the negative 4th. G of x is 6x to the negative 4th plus 7. So I look back up here to my definition. Let n be a non-negative integer. So I have a negative exponent, so this is not a polynomial, so I'm going to put negative exponent. Part C. The inside 9x to the 4th plus 16x squared looks like a polynomial, but I have a square root around the whole thing and I see nothing about a square root in the definition. So I will say no square root over variables. That's the reason why that is not a polynomial. Part D. D is in fact, okay, so it says 15x minus 2x to the 4th. That is a polynomial function. There aren't any weird exponents. I don't have any negative exponents. It fits the polynomial format, but it's not written correctly. The term that should be first is the minus 2x to the 4th. Then plus 15x. From highest to lowest exponent is how a polynomial should be written. That way it's easily to see what the degree is, so degree 4. And then the leading coefficient in that case is negative 2. The now try problem for example 1 is exercise 1. In exercises 1 through 6, determine which are polynomial functions. For those that are, state the degree and leading coefficient. For those that are not, explain why not. So, very similar to part B in example 1, I see a negative exponent. So this is not a polynomial. And we will say because, let's see, polynomials do not have negative exponents.